Good morning, Joyce. I still have 5 minutes.
Kiddos, how do we finish this problem?
Grabbing my notes will help.
So we have the range. We just gotta. So we're gonna have.
Because the range is the remainder. I know 47 out of 60, but I want to find a range of the actual sum.
We're gonna have 37 out of 60, and then.
Can you guys find me decimals?
I actually don't know decimals.
Well, 37 over 60 can make it a little more than half. 0.51.
Hold on, I have my calculator.
Is it less than or equal to, or is it just less than?
It should be less than 50, right?
Yes, good.
What am I doing?
You're doing negative 1/6 plus 47 over 60, aka same thing as what? 37 over 60?
And this one's 0.98. Let's go with sort.
And then 57 over 60.
So it's the first one is 0.61666.
For the first one?
Yeah.
0.16666?
Yeah.
0.61, right?
Oh, 61?
Yeah, that makes more sense.
Yeah, 0.616.
Oh, that makes more sense.
Yeah.
Sorry.
It's not 160.
The other one is 0.95.
0.95. Come on.
Keep going.
Oh,
Wait,
Oh,
even?
It was exactly, yeah.
Whoa, not.
above.
Wow, look at that range. That's pretty snazzy. So when they ask how accurate, we can say within. And we can say a couple different things. We can say it is
Plus or minus 47/60.
within 47/60ths of the actual sum, or we can actually write the actual sum and say, hey, it's between 0.616666 and 0.95. That kind of explains the how accurate is this estimate. But then they ask us another question, right? How many terms would we need to sum in order for the partial sum to be within 0.005?
Should we keep doing it?
Well, you could keep doing it, or keep finding the n plus first term until you find an n plus first term that is... Wait, hold on. Isn't there a formula for the n plus first term? Yeah. So then just, and then go again. Okay, so for the n plus first term, can't we say, hold on, this, let's make this letter A. Is that okay?
Yeah.
Wait, we have to first find the first 5 terms. That's that A.
B.
And then B, and then C. E, G. Okay, so we have 1 over n, right, guys? Is it as easy as that? So we want 1 over n plus 1, why? Because I want the n plus first term to be related how to 0.005. Why less than? You're right. I'm going to get you guys working on something in a second. I'll go back over. 1 over n plus 1, less than or equal to 0.005. True?
Yes.
So I need the error, which is the n plus first term, to be within 0.005.
Yes.
So can't we just solve it?
Yes.
Right? And n is the number of terms that we would find the partial sum. N plus 1 is the n plus first. Yeah, we can, because it'd be 5 over 10, 5 over 100, 5 over 1,000, right?
Yeah.
Do you want to do that instead?
I think so.
Sweet. So we have 1 over n plus 1 is less than or equal to 5 over 1,000. Isn't that the same thing as?
1 over 500. No.
Yeah. No.
225.
Wow.
That's rough. 1 over 200. Yay!
I was thinking that it was 2 over.
So we end up with n plus 1 is greater than, wait, why?
It's greater than, because we'll flip it.
Because I multiplied them to the other side, right? And then multiply it to 200. So now what?
Yay.
Good thing we didn't keep going on that one.
Good one?
It's a good thing we didn't keep going to find them.
Oh.
That would have taken a while.
Question?
Huh.
How come you flip the sign?
Because I multiplied up, and so now he's on the greater than side. Does that make sense? Now hold on, do we answer everything? How many terms would we need? So we would need at least 199. Does that make sense? And if you guys want to go ahead and check it out, what would be, if n was 199? Oh, wouldn't that just be 1 over 200, which would be 0.005? Uh-oh. Hold on. What's the key word it uses with 0.005?
Within.
Ah, if it says within, does that mean it's allowed to be 0.005? So what should we have done down here when we put the less than or equal to?
That's less than.
Which means if n has to be greater than 199, how many terms would we need in order to make it first be within?
200.
Exactly. Does that make sense? It says within 0.005. Within means my error needs to be less than 0.005. So if n has to be, at the end of all of our solving, if n has to be greater than 199, the first one, remember, by whole numbers, because n is which numbered term, n would have to equal 200. Does that make sense? Because then the error would be 1 over 201, which would be less than 0.005. All right, so all of this was us practicing which idea? How close we can approximate an alternating series with an nth partial sum. True? So, is there anything else we can use to practice? Yes. Number 31, I believe this is an exercise. Oh, wait. You guys have, hold on, number 9. Oh, do you look on your phones? Did I give you copies of the 9.2 to 9.6 homework? It's online. Okay, let's go check it out.
Yay.
Boop.
Check Yama.
Where am I? I don't know. Start.
You are there.
Misty, you're so helpful.
Look up. Talk all over.
What? Well, I figure if it was a question. Actually, this was an example even before, wasn't it? Haha! I was helpful beforehand. Okay. Handouts, right? Chapter 10 stuff. And then exercises. And then, uh-oh. There's more than 9 too, right? What? What now? It's been working for you guys though, right? Okay, my computer's been funny. Hopefully that's just it.
Are you just looking for what the instructions say?
I'm looking for the problem too.
Oh, I have it.
Oh, go team.
Sorry, I didn't.
No, I should have asked you. Okay, what's going on? Is it 37?
No, 31.
Oh, perfect. Okay, so I have the directions already. Determine the number of terms necessary to have the error of approximate be less than. But what's my series, Amanda?
It's n equals 1 to infinity, and then negative 1 to the n plus 1 over n.
Did you already do this one?
No.
Ready, set, go. Dun, dun, dun. Ready, set, go. No, I'm good. Thank you, Ruben. I might later, but for right now, I'm good.
Where's Karen?
Where's Karen? She's working today. She's doing the coffee thing. She's picking up some old shifts at the place where she used to work. She works at a coffee kiosk. It's a Santa Clarita little coffee shop, drive-through coffee shop. I think Dutch Brothers, but Southern California version.
We're gonna make
Can I go
everything.
visit?
Yeah, of course you
Get
can.
some coffee?
Although she's off at 2.
I can leave early.
Could leave right now.
Yeah, just go right now.
Okay, she put in orders. Just text her. Like, hey, this is George.
What's up, Karen?
When you come back?
Come back. This is coffee.
Wait. Although caffeine. Oh, we didn't go to the same place this year. When we would go to Forest Home, they wouldn't let the kids have coffee because they said that technically it is a controlled substance. No, how did they put it?
Stop.
And it's illegal to serve to minors.
I'm surprised that
How was
I
it?
haven't been kicked out of the school then.
It's a not controlled substance. How did they put it?
It's a drug.
Like it affects you. Yes. There you go. A stimulant.
I think they were just trying to get away with not having kids.
Not having kids steal all the creamers. Probably. But it seemed like a legal thing that they had dealt with before. I don't know.
I'm sure there's some kids that just get some medicines.
And it's just a struggle.
Stupid pre-calc kids, they call it coffee. They don't deserve to be in the this class.
Hey, you guys get the fresh coffee though.
That's true.
That's true.
Sacrifice. But either way, we have to force it to be more.
I don't understand.
Sam did it today.
Pre-cal kids don't even need coffee. Their life is so much easier.
I didn't
Any
do
football
section.
player drinks coffee, tell them no.
No. When they're in season or no anytime?
Anytime.
No,
It's
anytime.
also grow.
That's why you don't grow up.
We should sue.
It's
Like,
unsafe.
yeah.
That's why coaches don't like drink coffee, soda.
Then how'd you get so tall?
It's all natural.
There's less caffeine in stuff.
I mean, I'm decently tall though. That's the thing.
Never your girl.
So?
It only stunts guy growth.
Women's average height is shorter than men, so it's not much of a matter. Just
It also stunts other things. Women grow coffee, apparently.
such as
Everything.
pretty much.
So does gymnastics.
Oh, is that why Gabby Douglas is so short?
Yeah. I grew 4 inches a year.
Compared to
after
Shaquille O'Neal.
gymnastics.
Wasn't that the one going around?
What?
Wasn't the Gabby Douglas and Shaquille O'Neal picture going
Yeah,
around?
Yeah, it's so funny. Yes.
Why are the gymnastics gyms so small?
Because you're like constantly like pounding on all of your like joints, so it like stunts your arm. Something like that.
It's like when you start young. That makes sense.
Yeah. Which is why if you're tall, you can't really be a gymnast. So Nasty Lukin was like an exception.
That makes sense.
She's
The exception.
yeah. Because like for uneven bars, you hit your feet on the bar, which is a fun thing. And like when you're doing tumbling classes, if you're tall, you have like less room to actually.
If you're taller than Jeff.
No.
We're only doing C. Like what C of
Yeah, but you need to do A and B to get to C.
There you go.
No, we don't.
We're just thinking through how to answer this because this could be on a multiple choicey thing of the AP from time to time.
1 over
Up.
n plus
So-
n cubed is less than.
Why n plus 1 cubed?
Because it's n plus 1 in the. You replace n with n plus 1.
Yeah, remember for alternating series, for the alternating series remainder theorem, the s minus s sub n is less than or equal to a sub n plus 1. So what we're saying is that we need all of this to be within, and we can't figure out the actual sum. So we can't figure out this side because we don't know who that guy actually is. But what we can do is say, okay, if they want it within or less than 0.001, we'll put it over here. And wait a minute, if they say less than, is it less than or equal to? Oh wait, why isn't it showing? Freeze.
Oh, it's for.
Let it go.
9.
There we go.
Greater than 9.
Since we don't know who this guy is, then we can't work with that side, but they do tell us less than 0.001. So we can make this guy less than 0.001. That way this guy will be within, which is exactly what we're looking for. So we take the n plus first term, which is what Amanda was doing. We set it less than 0.001. As George said earlier, it might be easier to think about a fraction, so that'd be 1 over. So then I can go ahead and just do, remember, multiply up, the sign flips. N plus 1 cubed is greater than 1,000, right?
10.
Cube root both sides. Don't have to worry about signs, right? Because it's an odd powered root. So then n has to be greater than 9, which means that they're asking for determine the number of terms necessary to be less than. We would then go ahead and answer, okay, the next term would be 10. Dun, 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 dun. That's a new one.
And that tells us that to have the error.
Be less than 0.001, we need to find which partial sum, the 10th. If we find the 9th, it would be equal to 0.001.
Okay, so the a sub n plus 1 has to be within 0.00.
Exactly. Because we can't set this within because we don't know who that guy actually is, right?
Right.
We don't know the actual sum. So in order to get that guy within, we say, fine, well, you must be, right? He must be less than the n plus first term, so we'll set that guy less than 0.001. Does that make sense? Okay. Uh-oh, I'm going the wrong way. Okay. With that, look at you guys. You're ready to go. So for those of you that have already, Amanda, look at this one.
Wait, but I think I got it.
I think you did too. So why don't you and me work together on it? The rest of you guys can be collaborating or just benefiting from the trickiness of 49. And then, just maybe, wait a minute, what's due tomorrow? Homework 9.5 is due. Are we supposed to start 9.6 today?
Oh, not.
We were supposed to finish 9.5. Let's go check out our calendar and how off we are.
Let's hope our error is within 0.001.
Okay, so we're having a Forever Endeavor quiz tomorrow. No, not tomorrow, Friday. We're supposed to start 9.6 today. Technically, that guy we're moving over here because in class we decided to finish. I think we had 2 days of finishing. Oh well. There we go. And we need little parentheses because this is their chapter 9, not our chapter 9. It's our chapter 9. Nope, 10 intro. Okay, now we got it. And we can work on 9.6 tomorrow. We'll have 9.6 hopefully due on Friday, but it may very well go to Monday. And then the chapter 9 AP. How you guys doing on the chapter 9 AP?
I have some questions.
I have? Yeah.
Okay, then let's do this instead. You ready? Let's do this here.
Let's make our.
Let's do this uh-oh, come back screen, here. Let's do this here. You guys tracking? Let's do this.
What's going where?
Uh-oh.
Test is moving back today. AP's moving back today. Have a work day today.
So the AP's due Sunday?
Yeah.
Yep, better come into school. I'll be here.
I mean forward. How about that? Does that make sense?
Yeah.
It's backing up.
Let's do that. And then let's do that.
Last word on word and chapter 9.
How about that? That sound good? Then let's put this guy here. So then we'll start 9.6 tomorrow, finish 9.6 on
What's something for that?
Friday. It's up there for the possibility.
Yes, stomped on yesterday.
Screen is killing me, screen is killing me.
No, they tied once and then they dominated once.
Okay, so wait. So this guy is here. This guy is, ooh, how do you think about that?
Yes.
Okay, so long story short, today, I'm just giving you more time to procrastinate. Today, we are finishing 9.5 classwork on homework in Chapter 9 AP to try to catch up on life. That way tomorrow we can start 9.6, finish 9.6, and you guys can be focused on 9.6 in order to have the last of your Forever Endeavor tests to study for Monday. Then you will also have your Chapter 9 AP due on Monday, but hopefully we get a lot done today. And then test review on Tuesday, test on Wednesday. How's that sound?
Yes. Good.
Helpful. All right, cool kids. So the calendar is all up to date, so let's go ahead and come back here, and let's talk about number 49 real fast. Did I get it up there? I did. Let's talk about number 49 real fast. There we go.
Can we like go to the goals board, or are we doing it?
However, before talking about number, do you want everyone to go to the board to do it?
I want to go to the board and do it.
Without having me do it?
Yeah, I did it.
Oh, you already did it.
I'm good.
So is it too easy? We shouldn't go over it? Okay, instead of doing that, then I'll just save it for you guys. Can we just talk about, real quick, what to do with factorials?
Ooh, yes, please. Factorials are ugly, disgusting.
Now, hold on. This little guy is a little bit messed up. He technically should be, like, over here.
That makes sense.
Okay.
Or like just
Question. How do factorials work?
You take the number you're on and multiply by every integer below it.
So if we have variables, how could we write k plus 1? Factorial.
K plus K sub 1. Or, I guess not.
Why am I doing this?
Because you minus
Can we not read it? Hold on.
It's just k plus 1 times
Oh, I
k.
see. Yeah, I see.
Yeah, k plus 1 would be the highest
And
it
then
goes,
K.
right? And then k, and then
K minus
k minus 1. And then, wait, hold on.
K minus 2.
Can't I just, if I'm looking at the denominator and trying to compare, can't I just make this guy k factorial?
Yes.
Wouldn't k plus 1 just add one more term?
Yes.
And why is that good if I'm looking at these two?
Go bye with American Pie.
Oh, that's a lot nicer, right?
You say hot now?
Wow.
Now, hold on. Now you guys think about the next one. Take a couple seconds. Now this is when you have factorials on the top and the bottom. And if you notice, this is introducing the last two tests we're going to cover. But some of you were kind of like factorials, so we're just kind of at least getting a deeper grasp on what's going on.
I forgot about doing this.
Well, you couldn't have really used it on 49 anyway, and we'll talk about why. Because there's only a factorial on the bottom, right?
Yeah.
So it doesn't really work on 49. We'll get back there.
Limited
But on-
approach to infinities.
On this one, how would we simplify 2n plus 2 factorial over 2n?
Let's take out the 2's.
Nope, you can't take a 2 out of the factorial.
Oh, you just
Is
keep
it
going.
Really?
2n plus 2
Two
times
n.
2n plus 1
Times 2n.
to
Do you guys see it?
To that.
Because who's the one before? Who's the one before?
That blows.
But it makes sense though, right?
Why can't we factor that out?
Because
Would I be killing something?
n factorial, let's say 2n factorial, n was 10, right? That'd be 20 factorial, 20, 19, 18, 17, 16, 15. Does that equal 10 factorial, 10, 9, 8, 7, 6 times 2? That's why. So what's this end up equaling?
2n plus 2 times 2n plus 1. So 4n squared plus 6.
Now hold on. When have we seen functions put on top of each other and able to be simplified? Or maybe multiplied by the reciprocal of each other and able to be limit comparison test. So this is similar to a limit comparison test, except with a limit comparison test, don't we still want to know how to know the convergence or divergence of these guys? And the problem is, how do you know the convergence or divergence of those guys? So the test that is coming allows us to not have to do the limit comparison test fully and do something that's similar by taking a ratio. But anyway, we'll learn that tomorrow in section 9.6. Let's just talk really quickly about, wait, the last one?
1 over n to the 1 over n, right?
It's n to the 1 over n, and it's a special limit, so just 1. No, it's 1. It'd be n to the 0. Oh, wait.
Because if you plug
Oh,
in, if you flip it, it's negative n and then you get 1 over n.
Oh, no negative, no negative. We make the power 1 over n. And what does 1 over n approach as n goes to infinity? And anything to the 0 is 1, but double check, wait a minute, that's
Cells, right? 0 to infinity.
struggle. How do we, well, isn't this technically infinity to the 0?
Sorry, yeah.
But don't we have an Endeavor card of special converging sequences?
Yeah.
And isn't this one of them?
Maybe.
And doesn't it equal 1?
Yeah.
Thanks, guys. So let's go back to number 49 and say, stink, but this guy only has 1 factorial. So I'm not going to do the whole thing, but can someone at least give us an idea?
Well,
Limit as n approaches infinity of 1 over 2n plus 1 factorial.
Equals 0.
Which does equal 0, so condition 1 for alternating series is met. Condition 2 is that are the terms going to keep decreasing?
Yes.
People who have checked, they say yes. But how do we check for, right,
Have value.
Oh, God.
absolute convergence? We have to just consider the series n equals 1 to infinity of 1 over 2n plus 1 factorial. How do we?
It's always positive. So
You do direct comparison.
It's always positive. We don't want to do integral tests. Direct comparison, we could.
Yeah, you just do 1 over n.
However, you have to find someone who each of the terms n squared. Hold on. So if I plug in 1, that'd be 1. And 1 over 2 plus 1 is 3. 3 factorial is 1/6.
1 over n squared is just 1 over 1. 1 over
Is bigger
4.
for everybody.
It's bigger the whole way through.
Okay. So if 1 over n squared is bigger the whole way through, that would be one way. I was kind of looking at it instead to do limit comparison tests, but that was just me.
What's 4 factorial?
And I would have done,
Sure.
if it makes it easier, limit comparison.
Because it goes like 1 1, 1/2, 1/6, 1/4.
Well, I was just liking limit comparison. You don't actually have to think about it as far as which one's bigger or smaller. Hence why in the sense of like for every single individual term. So I was going to compare to n equals 1 to infinity of 1 over n squared. What would happen is you take the limit as n goes to infinity of 1 over 2n plus 1 factorial times n squared over 1. Which growth is greater, n squared or factorial? Yeah. So factorial is greater. Greater's on the bottom. The limit is 0. And what do we know about this guy? Converging by p series, right? We'll just say p. P series. So therefore, if the limit is 0, and I'm comparing to a converging sequence, what do I know about this guy? Yeah.
Misty, on the thing it said it starts at 0.
Oh, did I write it wrong?
I don't know, because like, if you start at 0, you have to change, if you start at 0, you have to change the bounds to make it comparable to.
Hence why limit comparison is a great idea. Remember, direct comparison is one of the harder ones. We don't necessarily want to make it fit if we can do limit comparison. But that's just my idea. All right, cool kids. Are we good with the work period on Chapter 9 AP and then the homework? Yeah. All right. Is that the same homework assignment? Anybody who wrote it down?
Oh,
Yeah.
yeah, well,
Ending
mom,
at
is
50
you put a
word.
9.4 up there, but there's nothing. 9.3, there's no paper for 79, or there's no,
Okay.
it doesn't go down.
So let's do that. And then let's do, it's a good idea, just I'm fine with us skipping as long as we're keeping track. But the nice thing is, guys, aren't we basically reviewing all the older tests by doing the newer tests?
Yeah, we are.
Nice. Go team.
So
So we'll just skip those two.
what do you think is more important, the homework or the AP?
Which one are you more prone to work on your own? It's not helpful whatsoever. Are you on track for your homework?
No.
Okay, then work on the AP.
Oh, awesome.
Or go back and work on your homework.
Can I see your instructions for?
All right, Joyce, they're going to work till the end of class. We might cover a couple questions, but you know how you're doing and what things you have questions on.
No, I
Talk to you later. Bye.